I think.
Okay, everybody. So please give a round of applause to João.
So, yeah, hello everyone. So I'm going to, give a presentation about 5 different issues that I have found while working in Kotlin at work, actually, and things that led to a bit of confusion and less productivity at work just because we didn't know what was going on. So I will talk about 5 different topics. One is about nullability. The other one is about inline and cross-inline. Then about tail call optimization in Kotlin. And then data classes. This was a real headache at work when working with especially with the Spring framework and with the annotations that it provides. And finally, something about the delegates and how can that work with the with annotations. So the first thing is that Kotlin promises a guarantee of null safety, and another thing is that although we can use nullable members in our classes, we really shouldn't whenever possible. So we should stick to using immutable data whenever possible. That sometimes is not compatible with with our requirements at work. But what we have found is a peculiar thing about Kotlin, and I would explain now with this example. So I have on GitHub a repository that has all the code that we can use to test this, and in it I have created a database using a flyway script. So when you start Spring Boot, it will run this. It is a simple table, and what I want you all to focus right at the beginning is that all of these columns that I am creating are not nullable. Sorry. And what that means is that we can put null values in them, and this is something that we see frequently in production. And now we want to apply code to it. We want to program this in Kotlin. So usually we do this. We create another class. We created an entity for it, and this is of course considering the repositories and all the things that we need to get the data to it. And here we do all this mapping, and this works fine. And another thing that I've done in the code is insert 2 car parts. One, the database is about car parts. The whole project is about car parts, by the way. And I'm inserting 2 different car parts. One is just a screw, and the other one is a car part without a name. It's just a null value. So I put that in the database. And then I created this test. And now this is specifically for the repository, but this, what do you think that will happen in this test? A compile error. Anyone has a different opinion? A warning, yeah? Yeah, it is indeed a nullable, a useless check. Oh yeah, I didn't say this before. Every single one of these examples, I have a practical example that I want to make, but it will take a lot of time. So when I'm done with the theoretical part, if there's time, then I will do the practical part to see this in action. But this test will run without a single problem. We will get a warning in IntelliJ that it's useless, that it's not doing anything, but this will work. The name, which is supposed to be not nullable, gets a null value. And we can see this with another simple example, because I'm trying to make a point here. And it is this example where I'm specifically using reflection to set a null value to this car part DTO. So now here I'm separately, without using Spring or anything like that. And I'm just saying, hey, I want to get the field, and then in this field, I'm going to set a null. And there's a difference between what I'm saying. I'm saying set, and I'm not saying assigning, because null safety does protect us from assigning a null value, but this is a set. So we are setting a null value in something that it's not supposed to be nullable. And so this code also works. So this created problems for us because we were getting nulls and we were just relying on the null safety that Kotlin provides. So this is the first example of something that caused issues for us at work. Second example is inline and crossinline, which can be used in combination with each other. Inline, I don't know who knows what inline is. Yeah, lots of people. And we all know what crossinline is? Less people. Yeah, you know. Yeah, so I hope I also know, because I think IntelliJ people right over here know a lot more than I do. But so this created also a bit of confusion because we were using cross-inline just to make the code compile, but not really understanding what it actually is about. And so why does this even matter? So I created a few examples to exemplify this. This is the first one. And here I'm just simply creating a higher order function called call engine crossinline. This basically is analogous to just starting a car. And this call engine crossinline makes these print lines, and it's being passed on here. I'm not sure if you can see the arrow. Yeah, you can. Okay. So, but I'm not using it anywhere inside this code, and I'm returning here. I'm doing here a local return to introduction, and nothing. The compiler isn't complaining. IntelliJ is not complaining about this, and we can do this very simply. And this, if we check on the decompiled code, we can see that the call engine crossinline has been inlined, and there's a call to a function in it, which uses the function that we passed through. And we see that in the decompilation, we also get this invoke with what we have put in the call for introduction. So nothing special here, but then I made another example where I'm calling this start manual inside of it. And IntelliJ forces us to use cross inline. And without it, it doesn't compile. But the thing is, we are forced to use cross inline. The code doesn't compile anyways without cross inline. So why do we need to put cross inline? Why does this affect the code? And couldn't IntelliJ just, or the compiler, figure this out on its own? Well, in this case, we can argue that, because we will never be able to make a non-local return, which is actually what the cross inline is about. So we can see here that I'm returning to introduction. This is a local return. A non-local return would be return loop, for example, in this case, or return call engine cross inline. This will be a non-local return. What cross inline is doing is saying to the compiler, those returns are not possible. But yeah, here we might say that it's not useful. But if we do it, if we follow this example, this other example that I've created, this is a bit different. It's just like going to a store, making a purchase, and then leaving. And I created here a go to store inline function. And with it, the compiler is letting me return to main, which is a non-local return. But if I return to main, I never leave the store, because this print never happens. And if we check the decompiled code, we see that this instruction never gets to the code. What cross-inline does to us is making sure that we only make local returns. So this means that we can kind of protect our code from making the wrong thing. And so the decompiled code now does has walkout, because of course we return a go to store. But what cross-inline actually does for us that is very useful is two things. It makes the code more readable, and it protects us from making mistakes. But we are developers, and there are some developers that will just remove cross-inline and do something just to make the code compile, and then maybe in that case it will not work. But that is the goal of this cross-inline. And I can't tell you how many times we've been putting cross-inline and removing it. And anyways, Then there's this tail call optimization. So this is something that has been created since the late 50s, and it was introduced in programming languages in the mid 70s. And the idea is that we can optimize tail recursive functions into something else that works better, and that is a transformation from our code into the bytecode that can occur with tail recursive functions. So what is the catch? Well, the thing is that I will show this in this example. So in this example, I have created classes, data classes that represent the car, a complex part, and a part. And all of these different data classes contain the weight, and the recursive function that I created will sum all the weights and just give us, the only goal is to give us the weight of the car. And so the way this function is implemented, maybe we could have implemented differently, but just for the example, is that it is a tail recursive function because the last call to the recursive function is the same, is the original call to the function. And so it's a bit difficult maybe to explain, but this total weight here is, when we call this, we're calling this function. When we're calling this, we're calling this function. So it is still recursive because of that. And when we apply tailrec, we are essentially just saying to the compiler that this function is still recursive, and it's up to the compiler to decide how it is going to transform this in the bytecode to make it more efficient and to make it eventually faster, but also to prevent one thing, which is stack overflow. Because the idea is I don't know if it happens in all different kind of optimizations, but in most of the optimizations that I've seen, what it does is just transform the recursive calls into iterative calls, which run no risk of throwing a stack overflow exception. And there's another curious thing about using tail recursive functions is that we can use immutable variables. And so we don't need to rely on a mutable variable to add values to it. And this is probably better explained in this bit where I do the decompilation. And in this case, we can see that what happened in the transformation is that it transformed that function into an endless while loop that will return once the list of parts is empty. And it has an accumulator that will, in every iteration, have a value added. So because there's only one stack frame, this will never generate a stack overflow exception. And you can see that the code is horrendous when we decompile it from the bytecode. But this is something that if we would do this in Kotlin or in Java, we would probably be enormously criticized for it, but it is highly efficient. So tailrec what does for us, and where it became clear is when we realized that this was just transforming a beautiful code into an efficient code underwater, and the code just becomes more readable. But of course, without tailrec, this would be a very inefficient code. Not this one, but the one I showed before. I think you get the point. Okay, so the other thing, and this was the biggest headache that we've had in our project, was working with data classes and frameworks. In this case, the Spring framework. Which one of you has worked with Spring framework? Yeah, almost everybody. Quarkus? Nice. And Ktor. Okay, whoever worked with Ktor will never find this problem, I think. So, yeah, I'm not commercializing it, but it is true because I think Ktor doesn't use annotations or no, yeah. Depends for what. Okay, then maybe. But in any case, the Spring framework is something that's used widely today, and what I'm about to show was a bit of a headache. So here we have an example. This is an entity that I've created with some validations on it. So I'm saying not null for some reason. It's not necessary in Kotlin, but it's here just for the example. And there's size and there's min. Who thinks that this table will work? Okay, nobody thinks that this will work. You think it will work? It should. Yeah. Yeah. With plugins. Yeah. Yeah. Okay. With the Spring plugins and that. Okay. It will not work even with plugins because there is something which is use side targets. And in Java, what we used to do with annotations was just apply them physically in different locations in a method or in a field or in a property, because we would have that. But in Kotlin, in data classes, you only have class members. So if I say here apply size to name, where is that? Is that in the constructor? Is that in fields? Where is that? So Kotlin does have a rule for this, and I will show that in a minute. But what I did for this to work was to add here field. And the reason why this now works is because of rules that Kotlin has. And in my experience, the problem is that we were just constantly Googling this stuff and going to Stack Overflow to all the wrong places to see this. And we didn't come across the documentation with Kotlin, which says that if you don't specify a use-side target, the target is chosen according to the target annotation of the annotation being applied. If there are multiple applicable targets, the first applicable target from the following list is used. So if we have a look at one of these annotations where I had to put field, we can see that they are targeted by method, field, annotate type, constructor, parameter, and type use. So which one will be chosen by Kotlin? Which one do you think it will be chosen by Kotlin in this case to be applied to? Parameter. Yeah, it will apply to parameter. And the thing is that the Spring framework uses AOP to apply validations. And it doesn't provide good support for parameters. And because of that, this gets applied to a parameter. And we can see here in the decompiled code that min and size are now applied as a parameter for the constructor, and this will never be used. And so the validation will never work. And this, if you're working in a kind of project where unit tests are less relevant or something like then you will not see this. And when you realize it, then it's a problem because, where does the error comes from? And so when we apply this field prefix, this use side target, before the annotation, then we are forcing Kotlin to choose the field of the class to apply this annotation. So all of that work. And actually, this was so simple. And this works for all the other kind of use side targets that we can choose to different kind of annotations. In this case, I'm just using validations, but this could be for anything else. And then finally, something special that I've learned with delegation, and that is, because in Kotlin, one of the use side targets is delegation, and we tried to use delegation in our code, but it wasn't really working. It wasn't doing what we wanted to do, and I wanted to have an example to figure out how does the delegation use side target actually works. Does it work on delegates? Does it work on how does it actually work? And so I've created an example, in this case with horns. So I've created an interface horn with a car horn and a wagon horn. I'm not going to pronounce those sounds, but it's kind of just for the example. And I've created annotations for the example. And I've created a sound delegate with only a get value. And then I've applied these annotations with a delegate use side target on the definition of these fields, which are being created using a delegate. And so where do you think that this delegate annotation will be applied to? Will it be on horn or the sound delegate. Because we are creating wagon horn. This is actually a wagon horn, but it's by sound delegate, so it comes from the sound delegate. Where do you think this would be applied? Yeah. Yeah, it's kind of obvious. In this case, it's kind of obvious because, yeah, and then we see it here, yeah, that it applies to sound delegate, as we can see here. And this is kind of, in this case, is obvious. It's just a bit of a warm-up for the next exercise. And we can see, but we can see also another thing, which is the get wagon horn is here as well. And so this was interesting to me because I've also found other people on other forums that kind of got stuck here. And this was a very strange result to have. And so I continued and I created another example. And this example is a part name DTO and an impossible part name DTO. If we look at the impossible part name DTO, we are applying 2 delegates, and we are saying they're not blank, and the size must be 12. But when we do that, what happens is that we are applying the not blank in size to a sanitized name delegate. Maybe I could have chosen a better name for the delegate, but and what happens here is that how would this work when we are serializing data this way? It won't work because not blank and size, these are things that have to be applied to string. So we will get an error here about the mapping not working correctly. This one here does it well, and it applies these validations to the actual getter of the value that we are trying to put out via the delegate. And so I've picked up with these 2 information, I've created this example. And this is something that maybe we shouldn't do in Spring, but I did it anyways. It is just creating a delegate, creating this field current date using the delegate inside a service and then injecting the service. The reason is because I want Spring to apply its so-called magic, and that I could see the result of what is happening. And what I saw here is that I have created a delegate. I created a local datetime validator constraint. And this is a manual constraint that I can apply with delegate. And one thing here that I want to mention, this delegate site target apparently is only applicable when we have the target field applied to our annotation, which does make sense. And so what happens here is this result, which is the delegate has this local datetime validator constraint, and the date has to be in the past. So we have 2 validations working together. One is going to validate the delegate itself, and the other is going to validate just the date. And so, oh, not yet. And so, yeah, I can't change it like that. But I think we have time still for the examples or not. 10 minutes, yeah. I will start from the, yeah, which one do you want to see as an example? Anyone? If I have a benchmark, I have, no, I don't have a benchmark for it. Not ready for now. I don't have it for this session, but yeah, because you want to see the Stack Overflow being generated, or
know it we're buying it. Can be not more time, but like how much more off the time you have to wait.
Oh, the most important thing is not so much the optimization, because it's already tail recursive, so it's already very efficient on its own. The best thing that you have with the tail call optimization is actually the avoidance of Stack Overflow. because there's no stack frames. So time and space is pretty good already with tail recursivity. It's just that you don't generate different stacks in one inside the other, inside the other, inside the other. So at some point it just blows up. That's what we are trying to avoid with tail rec. So I did mention efficiency. It can be a part of it, but it's not the actual goal. Now, so the question remains: anyone wants to see? Yeah. So tail call optimization? Yeah. It will fail. Yeah, tail rec can be used. Tail and compile time. So it will. That is another. Indeed, there's another benefit to using it. It will tell you if your function is applicable, if your function is tail recursive, and then the compiler will do the rest. It will check if it can optimize it, how it can optimize it. But that process, I think people from JetBrains can tell you better than I can, because I don't know the details of that. But yeah. The compiler cannot figure that out by itself. It needs to have the tail. You need to apply it first, and then it will see if your function is applicable or not. So IntelliJ will immediately tell you this is or this is not tail recursive, and then the rest is up to the compiler. Oh, yeah. I think I'll try to answer on behalf of IntelliJ, because I think this is where it's going to be. It is about, in many languages before Kotlin, and I think Scala as well, but that I'm not entirely sure, you didn't have the choice. It was automatic for you. Kotlin, yeah, I think so. Not tail rec, but the tail call optimization. But you can decide if you want that or not. So if you have concerns about what is going to happen in the bytecode, you can decide not to use it. That's why, yeah.
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 And you might want to see if something happens. And you might want to see the code or your device.
Yeah. Yeah. Okay. So yeah. So yeah. So I want to show something else. I think did I stop the? Oh yeah. How did I do that? Let me go back to it. This one. Join. And then, yeah, but I think I closed the slide went down. 1 second, sorry about this. Yeah. So, yeah. Yes. Yeah. 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 Okay. So what I wanted to do with this presentation was to help understand better the Kotlin language and avoid colleagues of mine not to go through these problems, which they now sound very basic to me, but when I go back to that time, they were really annoying and difficult to solve, just because we didn't know better, and maybe because we need to think more about important things like not fighting the Spring framework or Quarkus. People usually say that they are evil and they are magic. I don't think they are. I do think that Ktor is a great development. So, but a lot of the things that we call magic in Spring are not really magic. We just don't know better, and sometimes we try to find the information in the wrong places. Like, for example, for Kotlin, I found out for myself that it's much better to go straight to Kotlin Lang instead of going to Google or something like that, because we are going to get a lot of tips and advices, but in the people are going to say just use field and it works. And then if you run into another problem, you will apply field and it just won't work. Nothing is perfect, and I think that Kotlin falls also in that category. Sorry, JetBrains. But yeah, but we have seen already that there are constant developments in Kotlin, and I think I am pretty much a fan of Kotlin. I do like to criticize it also, but I think that's what keeps my interest on it. And so that's a bit of the message I want to bring with this presentation. So thank you. And sorry, John, yeah. And I have made the repo with all of these examples is available on GitHub. So it is, yeah, questions. And these are the resources that I used. And the repo, I've put this image on it, and it's essentially with my user handle. So I don't know how to pronounce this even in English. J Esperancinha, something like that, and then / Kotlin mystery. So there are all of these examples that you can use to test these things out. And that's the end of.
Yeah. So thank you so much, João. Guys, we don't really have time for questions now. We're going to have a break of 5 or 10 minutes, so you can go to the toilet, grab another beer. And when we come back, we're going to have the talk from Jeroen. And you can also connect with João and Johan and Jeroen as well outside while we wait for not with Jeroen actually, because he's going to be setting up the thing, sorry. Yeah, and also João didn't say it, but he has a YouTube channel with a lot of great videos about Kotlin, around 100 videos, right? That's how I came across him, and that's why I invited him today. So if you guys are interested, you can also check him up on YouTube. Yeah, that's my part. That's why I'm doing it. Yeah. Okay. Thank you, and see you all in 5 to 10 minutes.
I just want to say thank you to JetBrains and the Dutch Kotlin user group for allowing me to share this video on my channel. And until the next video, be sure to stay tech, keep programming, be kind, and have a good one. Bye. I've updated my disclaimer to better reflect my position. This video is not sponsored and I have not received financial compensation for its content. Any brands, products, or companies mentioned are for informational purposes only. While I may participate in various programs, meetups, and conferences, all opinions expressed here are my own.